Imagine sitting in a room where, millions of years ago, the ground beneath you boiled at 4,500 degrees Celsius. Now picture this same spot buried under thick ice sheets for another million years. Both scenarios are historical truths of our planet. Before Earth or any other planet existed, our solar system was a chaotic cloud of cosmic dust and gas. This cloud, disturbed by a nearby supernova, began to collapse under its own gravity, leading to the formation of the Sun at its core. As the Sun ignited, leftover material began coalescing into various celestial bodies, including our own Earth. Initially, Earth was a fiery molten sphere, inhospitable and barren. During this tumultuous time, a significant event occurred. Theia, a planetary-sized body, collided with the young Earth. This colossal impact threw debris into orbit around Earth, which eventually coalesced to form the Moon. In the early eons, Earth resembled less the blue orb we know today, and more a fiery hell. The surface was a molten landscape, with temperatures soaring above 1,000 degrees Celsius. As the planet cooled, heavier elements like iron sank to form the core, while lighter materials formed the crust. This differentiation laid the foundation for a stable planetary body. The cooling also allowed for the solidification of the crust, setting the stage for the next chapter in Earth's history, the arrival of water and life's building blocks. Meteorites bombarded the young Earth, but they were not mere harbingers of destruction. These celestial objects carried with them water and essential minerals, crucial for the development of life. As these meteorites dissolved into the primordial seas, they not only contributed to the water volume but also introduced various minerals and salts. This era set the stage for the emergence of life, beginning with simple microscopic organisms. As Earth continued to cool, its geological activity did not cease. Volcanoes played a crucial role, not just as agents of destruction, but as creators of new land masses. These volcanic islands gradually coalesced into larger landforms, marking the transition from scattered islands to continuous continents. This era was defined by extensive volcanic activity, which reshaped the planet's surface. Microorganisms, thriving in Earth's oceans, began producing oxygen through photosynthesis. This biological innovation had profound effects on the planet. As oxygen levels increased, it led to the formation of the ozone layer, which protected the surface from harmful solar radiation. This environmental shift allowed for more complex life forms to develop and thrive. Periodically, Earth's surface temperature plummeted, leading to extensive ice ages. These periods were characterized by massive ice sheets covering large parts of the planet. Despite the harsh conditions, life found ways to adapt and survive. Volcanic activity eventually contributed to the warming of the planet, aiding in the melting of ice and the restoration of more temperate conditions. Dinosaurs, the iconic prehistoric creatures, dominated Earth for millions of years. They adapted to various ecological niches, from towering herbivores to fearsome predators. However, their reign ended abruptly with the impact of a massive asteroid. This catastrophic event triggered a global environmental crisis that led to the mass extinction of dinosaurs, paving the way for mammals to rise. In the post-dinosaur world, mammals flourished. Among these, primates evolved, eventually giving rise to humans. Our ancestors leveraged intelligence and adaptability to dominate the planet. Humans have made indelible marks on Earth, from the development of agriculture to the Industrial Revolution, affecting the planet in profound ways. Today, Earth faces significant challenges, from climate change to biodiversity loss. Understanding our planet's past can inform our actions to secure a sustainable future. As we speculate on future changes, it is crucial to remember the resilience and adaptability that life on Earth has shown throughout its history. Our actions today will shape the Earth of tomorrow. In the cosmic void, a nebula of dust and gas collapsed under gravity, igniting to form our Sun. The leftover material, swirling in this solar nursery, coalesced into planets, including Earth. During its early formation, Earth was a chaotic mixture of molten rock and metal. This violent period was marked by frequent collisions, including a significant impact that likely formed the Moon. This era set the stage for Earth's journey from a fiery ball of lava to a structured planet with distinct layers and a magnetic field, crucial for protecting the forming atmosphere. Picture the early Earth as a glowing, turbulent ocean of magma, constantly stirred by solar tides and meteor impacts. This Hadean eon, aptly named after Hades, was inhospitable but critical. As the planet cooled, gases trapped within the molten mass began to escape, forming the first primitive atmosphere, composed mainly of water vapor, carbon dioxide, and ammonia. The solidification of the crust eventually created the first land masses, although they would be repeatedly melted and reformed by continuous volcanic activity. Earth's surface was incessantly bombarded by meteorites, which played a dual role as destroyers and creators. These cosmic messengers brought water and organic compounds, essential ingredients for life. As the Earth cooled, these materials contributed to the formation of vast oceans, setting the stage for the origin of life. The first simple organisms likely emerged in these primordial waters, utilizing the minerals dissolved in them. During the Archean eon, life began to flourish in the form of simple microorganisms. The fossilized remains of stromatolites from this period provide evidence of early biological activity. The introduction of photosynthesis by these microorganisms led to the gradual accumulation of oxygen in the atmosphere, a revolutionary development that changed Earth's chemistry and paved the way for aerobic life forms. This oxygenation of the atmosphere was a pivotal moment in Earth's history, setting the stage for the complex ecosystems that would follow. Earth's climate oscillated between extremes. The Proterozoic eon witnessed the planet's first severe ice ages, known as Snowball Earth, where ice sheets possibly covered the globe. Amid these ice ages, life demonstrated remarkable resilience and adaptability, leading to the evolution of more complex multicellular organisms. This era also witnessed the formation of Rodinia, a supercontinent that would influence global climate and biological diversity. These global ice events played a crucial role in shaping the evolutionary path of life, challenging organisms to adapt or perish. The Phanerozoic eon, starting about 540 million years ago, is known for the Cambrian explosion, a sudden diversification in life forms, filling the oceans with complex animals. This era is famously associated with the age of dinosaurs, magnificent creatures that dominated the land for over 160 million years. However, their reign ended abruptly due to a catastrophic asteroid impact, highlighting the vulnerability of life to cosmic events. The subsequent mass extinctions reset the ecological balance, allowing new life forms, including mammals, to emerge and diversify. Following the dinosaurs' extinction, mammals rose to prominence. The cooler, variable climates of the Cenozoic era favored the evolution of diverse mammalian species, from massive woolly mammoths to tiny shrews. Primates too evolved during this time, with one lineage eventually leading to humans. Our ancestors' development of bipedalism, tool use, and complex social structures marked a significant evolutionary leap. Humanity's impact began modestly, but has grown exponentially, influencing every corner of the planet. In what many scientists call the Anthropocene, human activities have become the dominant influence on the environment and climate. Our actions have led to deforestation, pollution, and the ongoing climate crisis, posing threats to the delicate balance that sustains life. The rate of species extinction has accelerated, ecosystems are in flux, and the future seems uncertain. Our geological footprint is profound, with significant implications for all life on Earth. As we stand on the brink of potential ecological collapse, the lessons from Earth's past are more relevant than ever. Understanding the resilience and adaptability of life throughout history can guide our efforts to forge a sustainable future. We face choices that will determine the legacy of the Anthropocene. Will we continue down a path of destruction, or will we learn from the past to foster a resilient, thriving planet? In conclusion, Earth's journey through time is a saga of transformation and resilience, a narrative of how life and the planet have shaped each other.